we see a widening gap between what is taught in education and what industry requires. Traditional learning focuses on isolated models, but in industry, AI is embedded in live systems and needs to drive business outcomes. The key insight is that industry needs engineers who understand systems, not just models. In companies, AI is infrastructure, not the product itself. The system flow begins with the user generating events. The business system routes data and applies logic. The AI model layer scores, classifies, and predicts. Finally, the decision or output triggers an action and logs the result, feeding back into the system to improve the model over time. AI fits into a system architecture across 4 key levels. Data collection handles sensors and user events. Processing and storage manages ETL pipelines and data warehouses. The AI model layer is where training, inference, and serving endpoints occur. Finally, decisions and actions involve APIs, UI triggers, and automated workflows. The data flows down through these layers. The core mental model for an AI system flow involves 5 steps: user action, data flow, model predicts, system acts, and the feedback loop. This continuous cycle ensures that the system's outcomes are logged and feed back to improve the model over time. In a recommendation loop, the user watches content or clicks, and this behavior data is captured. The AI predicts preferences and scores all content. Top-end results are ranked, shown, and the user's engagement is logged back, driving the next training cycle. Examples include systems from Netflix and YouTube. The recommendation pipeline moves step by step. Data ingestion streams raw events via Kafka. Feature engineering processes data, like watch history. Model prediction uses collaborative filtering or transformers. Ranking logic applies business rules to model scores. Finally, the UI display renders the top results in the product. Data artifacts support each stage. In churn prediction, the process starts when a usage drop is detected. Key features like login frequency and plan tier are extracted. The model generates a churn score, which is then classified into a risk level. An action is triggered, such as an offer or an alert, to retain high LTV customers before they churn. For real-time anomaly detection, a transaction is initiated at t equals 0 ms. Features are extracted by t equals 5 ms. The anomaly score is computed by t equals 20 milliseconds, returning a fraud probability. The decision engine performs a rule and threshold check by t equals 22 milliseconds, leading to the final action of allow, flag, or block by t equals 25 ms. Critical constraints include low latency, high precision, good recall, and explainability. Across all use cases, a cross-industry pattern emerges, centered on 3 pillars: data, AI, and action. Data serves as the foundation, transforming user events into features. AI is the intelligence, generating predictions and scores. Action is the business layer, where systems make decisions and automated responses affect real outcomes. The feedback loop connects action back to data, continuously improving the AI. The engineer's roadmap should prioritize understanding the full stack. This involves moving beyond models as the foundation, up to learning system-level thinking and understanding data pipelines. Above all, engineers must learn to connect AI to business value and, ultimately, build solutions that affect revenue. The engineer who understands the full stack, from data to decision, builds real products.